Hey, so this is going to be questions 4 and 5, still related rates, but these two are very similar to each other, so I thought I'd put them on the same video. So, an inverted circular cone. So whenever we see those, let's draw our cone, and there's water inside this cone. The water has a radius of r and a height of h. The cone has a radius of 2 and a height of 4. So looking at these triangles, if I drew a right triangle, the radius of the cone is 2 and the height of the cone is 4. The radius of the water is r and the height is h. So I can write a ratio that the radius of the water to the height of the water is proportional to the radius of the cone to the height of the cone. Now 2 over 4 reduces to 1/2. And then I can say that r is equal to h over 2. Now when I want to use this volume formula, volume is equal to 1/3 pi r squared h, where I can put in h over 2 for r. Multiplying that out, the volume is equal to, well, when I square a fraction, I square the numerator and the denominator. So in the numerator, I'm going to have pi h cubed over 3 times 4 is 12. Let's take the derivative of both sides. dv dt is equal to 3 pi h squared over 12, so pi h squared over 4 dh dt. Water is being pumped into the tank at a rate of 2, so this is dv dt, and h is equal to 3, so this is h. 3 equals, 2. Oh no. 2 is equal to pi times 3 squared over 4 dh dt. Multiply both sides by 4. 8 is equal to 9 pi dh dt. dh dt will equal 8 over 9 pi. Question 5 is very similar because they're both dealing with a cone and water inside of that. So we have a cone, we have water inside that cone, the radius of the water is r, the height of the water is h, the radius of this cone, if the diameter is 4, the radius is 2, and the height is equal to 6. So we still have those two right triangles, 2, 6, r, h, but now r over h is equal to 1/3, because 2 over 6 is 1/3, so r is equal to h over 3. And we'll put in h over 3. h over 3 squared, this quantity is h squared over 9. So when we multiply that out, we have the volume in terms of h is equal to pi h cubed over 27, because 9 times 3 is 27. B. The rate at which water is being pumped in. So whenever we have rate, think derivative. So dv dt is equal to pi h squared over 9, because 3 over 27 reduces, dh dt. We were told that water is leaking out at a rate of 10,000, and we're also pouring water in. So there's water being poured in. So let's think about this as like the rate in, and this as the rate out. So dV dt is equal to the rate in minus the rate out. And we have pi h squared over 9 dh dt. We don't know the rate at which it's being pumped in. We know that it's leaking out at a rate of 10,000. And the height is 2. So this is h, and then the water level is rising, so this is dh dt. So we have pi times 2 squared over 9 times 20. The rate in is going to be equal to 4 times 20 is 80 pi over 9 plus 10,000. And then the units on this are going to be cubic centimeters per minute. Okay, so that was questions 4 and 5. Now we'll do questions 6 to 9, which are the position, velocity, and acceleration ones on a different one.